Matlab Masterclass. In this class I'm going to create a graphical user interface for Matlab, and then having got that working I'm going to deploy that as an executable program for Windows. What I'm intending to do is to create a function of the form y is equal to e to the minus ax times cos bx, which is a damped simple harmonic motion. I want to create that function and then draw it over a range of values and display that on the screen. I also want to have two input boxes so I can change the values of A and B, so that I can change the damping and the frequency of the cosine curve. So let's get started. The first thing I want to do is to create a new graphical user interface, and I'll use a blank GUI, graphical user interface. A little bit wider. So the first thing I'm going to do is to put on a text box at the top here, and if I double click on that I get the object inspector, and here I'm going to change the contents of the string to be y is equal to e to the power of minus ax times cos bx. Yep, alright, so you see I've typed the box and the cos part of it's missing, so I need to stretch that box so that we can see the cos part. There we go. So that's the function that I'm working to. Let's move that into the box above it. Now I'm going to have another text box. I'll put that here, and in that I'm going to write a equals, and I'll have a third text box which I'll put in the bottom here. Double click on that and change the text to b is equal to. Now in the next box I want to put an input, which I'll put here. Okay, and in here I'm going to put a value of I don't know, 0.1, and then we'll have another text box here. Let's just put that into the same place, and we'll put a value into that of 0.5, say. And then the final thing I need for my user interface is a button, which is this one here. I'll put that into this box. Let's change the, and I'm just going to call that the plot button. And then I need axes on which to plot the data. So those are my axes. Right, so we've got a title, we've got A is equal to, B is equal to, a button to say do it, and then some axes on which to draw it. So I'm going to save that now. Click on the save button, and I'm going to call this mc1. That gets saved, and you see automatically it's created an mc1.m, which is a Matlab script. So mc1.fig is the figure of our graphical user interface, and mc1.m is the project that we've created here, and mc1.proj is the project that holds the whole thing together. Just looking at this, we've got push button 1 callback. That's the function that gets called when we click on the button that we've put on the screen. So before we write our program, I'd like to see how we get data from the objects on the screen and put data back into the object on the screen. Now, to get data from an object or to put data in an object, we use the object's handle, and all of the handles of all of the objects on the screen are held in this variable here. So what I'm going to do is I'm going to say, I'll tell you now, I'm going to make two mistakes so you can see how we handle the mistakes. So A is equal to get brackets handles, So that says I want to work with a screen. Then I'm going to say rbox, which is edit 1. Then I'm going to say what I'd like out of that object, and that's going to be a string. Okay, we'll close that, and we'll set that value equal to the contents of edit 2. So I'm going to say set handles dot edit 2, and then I want to put into it a string, and I want to put the value of a into that. Okay, let's save that, and then we'll run it. And here immediately you can see it's telling me on line 127 the string hasn't been terminated, and that's this red here with the squiggly underline, which you probably noticed already. So if I put the semicolon in the end of that, that will now fix it. I'll save that, and then we'll run the program. And here it is, fired up on the other screen. There's A, there's B. If I press the plot command, what should happen is that the value of 0.1 gets put into the box where 0.5 is displayed. But when I click it, actually I get an error. And this error, you may not know, is because I've called this edit1.text. And if I look at our graphical user interface, its name is actually lowercase edit1.text, so it is case sensitive. So if I go back to the Matlab script, which is here, I can change that to lowercase edit1, and now I'll change this to lowercase edit2. Save that, run it. A is equal to 0.1, B is equal to 0.5. If I click on plot, B is now equal to 0.5. Right, that's working. There's one other thing I'd like to do. I'm going to try to say that B is equal to 2 times whatever is in A. So I've multiplied that by 2, save that, and run that again. So A is 0.1, B is currently 0.5, press the plot command, and I've got an error. Why have I got an error? Well, the answer is A is at the moment is a string of characters. The characters are actually numbers, but it's still a string of characters, it's not a number. So I actually have to convert this into a number before I can do what I'm trying to do here. So I've got to use a function called str to double, that's to say string to double. So it's str to double, put that in a bracket, put a bracket at the end there. This part will get the string, and then this part will convert the string into a double precision floating point number. So save that, run the program, and this time 0.1, 0.5, click the plot command, and that's now 0.2. So that's worked correctly in the way that I wanted it to. So now we can get on and write the program. So A is equal to that, copy paste, B is equal to string 2, edit 2. I need a variable called x, and that's going to go from 0 in steps of 0.1 to 100. That's my x variable. And then what I want to do is to say that y is equal to exp, that's the exponential command, to the minus a times x times cos of b times x. Right, so then when I save that and run it, I get my user interface. I'll stay with those variables there. I click the plot command and I've got another error. Okay, so what's gone wrong this time? The answer is e to the minus ax will give me a number, and cos b to the x will give me a separate number, which means instead of multiplying matrices together, I've actually got to multiply just the numbers together. So I need to put a decimal point in there. So we'll save that and then run it. So we'll plot it, and there we've got our values of y. Okay, so the next thing I want to do is actually to plot that onto the screen. So I'm going to say plot x comma y. Save that, run that, plot it, and there we go. We've now got a graph of x against y, and there are 1001, not Dalmatians, but data points on that. So now let's decrease the damping. So let's make that 0.5, plot it again. Okay, there's less damping there. Let's reduce the damping even further. Okay, and if I take the damping down to 0, then clearly there's no damping and we just get an ordinary cosine. Bring the damping back up again, and we've got a damped simple harmonic motion. Okay, and I can change the frequency by changing this. If I make it, I don't know, 1, you can see we've got a higher frequency. If I take that down to 0.25, let's say, I have a lower frequency. So that's now a working Matlab script in a graphical user interface. Now if you wanted to share this with colleagues, one way to do it would be to create an executable that they could install on their computer. So that's what we're going to do next. So to do that, in the command window, we need to invoke the command which is called deploy tool. We're going to use an application compiler, and we need to add our main file to it, which is mc1. This is a splash screen that will show up when the program opens. We can change that to something of our own if we want to. I'm going to save that project, and now I'm going to create the package. This takes a bit of time. And there we go. So let's just have a look at the folders that it's created. It's created one folder here for testing, and there's our executable mc1.exe. And here for redistribution, it's got a Windows installer, which is what you would send to colleagues so they could install that on their machine. Let's just check it by going to the testing program, fire up that exe, there's the splash screen, followed by our application. And if I click the plot button, it seems to have changed its view somewhat, but if I click on plot, there's a plot. Change that to 0.5, click on plot, and there's a plot. So to summarize, we created a graphical user interface, we added the data that we wanted, we got that working properly, and then we converted that into an executable program, which, if you've never created an executable program before, I have to say that's the quickest way you can do it. Okay, this is the end of the lesson.